In this Q&A video, we're going to answer the question, how do I make sure that containment will take the weight of the cables in it? Just before we explain the answer to this question, please be aware that this video is one of a series that we've made on the subject of containment in association with Marshall Toughflex. They can be viewed individually, or you can click the link in the description below to view them as part of a free online training package to help you with your CPD and receive a certificate to prove that you've completed the course. If you've handled, carried, dragged in or installed armoured cables, you very quickly start to appreciate just how heavy they can be. Multiply this weight by the number of cables that you've got installed on a piece of cable tray, and very soon you can be trusting that your installation will hold up the weight of, say, a small herd of cows. So how do you know that it will indeed support your bovine-esque cable installations? Well, the first place to start is with the containment itself. We're going to demonstrate the principle of how to do this using this cable tray from Marshall Toughflex. It's a 300mm wide piece of tray like you'll see in industrial and commercial installations across the globe, but how many cables can we install on here? Well, as with so many things in the electrical industry, we refer back to manufacturer's instructions, or in this case, information. Marshall Toughflex have published information in their catalogues and online about the characteristics of their containment, and one of these relates to how much physical load they can bear. So let's take our 300mm cable tray. It comes in 3 different grades: light, medium and heavy duty. The major difference between these is the height of the flanges or vertical sections of the tray. This affects what's called the bending moment of the tray. Basically, it just means that the higher side makes the tray stiffer and stops it from buckling so it can take more weight. The trays are load rated in kilograms per metre, so you can see the light gauge is rated at 11.8 kilograms per metre, the medium duty at 16.8 kilograms per metre, and the heavy duty at 35.3 kilograms per metre. There's a couple of different ways that we can use this information. We can either figure out exactly what's going to be on the tray and check that it's suitable, or we can figure out a total number of cables that we could install on it. Let's have a go at the first option to start with. Let's say we're going to install some submains and a few smaller circuits along here, all run in steel wire armoured. So a 35mm 4-core and 3 25mm 4-core SWAs, all of those with separate 16mm CPCs, 4 6mm 4-cores for 3-phase EV supplies, and 6 2.5mm 3-cores for miscellaneous power circuits. How much is this all going to weigh? Well, we can turn to manufacturer's data from a cable company to get that information. We're going to be installing armoureds from Doncaster Cables here, so if we look at the data sheets for their cables, you can see they include the weights of the cables. Notice though, they state their weights in kilograms per kilometre rather than per metre. So to make the values align with each other, we need to divide these weights by 1000. This will convert the values into kilograms per metre. So all we need to do is add up the total weights of each type of cable. The 35mm cable weighs 2,400 kilos per kilometre, so dividing by 1000 gives us 2.4 kilos per metre. From here, I'll just assume you'll remember that we're dividing by 1000 in each case because we wouldn't want this to get tedious. The 25mm cable weighs 1.9 kilos per metre, and we've got 3 of those, so that's 1.9 times 3, which gives us 5.7 kilos. Now at this point you may be looking at the separate 16mm CPCs and wondering if it's worth even counting that, but even these will start to add up and have an effect. We wouldn't want a straw versus camel's back situation coming in here. So looking up the data on singles over on the Doncaster Cables sheets, we find that they have a weight of 0.175 kilos per metre. 4 of those comes to 0.525 kilos. Then we've got the 6mm 4-cores, which are 0.68 kilos per metre. 4 of those comes to 2.72 kilos. And finally, the 2.5mm 3-cores have a weight of 0.32 kilos per metre. 6 of those comes to 1.92 kilos. So adding up our total weights comes to 13.44 kilos per metre of installed tray and cables. So if we compare this value to the 3 duties of cable tray from the Marshall Toughflex catalogue, you can see that the light duty tray has a filling load of 11.8 kilos per metre, meaning as our total weight of cables is above this, we'd need to look at the next grade up, which is medium duty. That has a filling load of 16.8 kilograms per metre, so that would be totally acceptable in this case. If we were to think about installing even more cables, which would be tricky as it's so very full, then we might have to go to the next grade up or possibly even install a wider tray. The other way of using these load figures for tray is to figure out the maximum number of cables that it can carry. To do this, we'd take the maximum load value and divide it by a known weight of cable. So in our example tray at 300mm, we know that it has a filling load of 16.8 kilograms per metre. Let's say we want to load it up with 25mm 4-core armoured cables. I reckon I could just about squeeze 10 of those on here, but would that be okay? Well, each one weighs approximately 1.9 kilos per metre, so we'd take the 16.8 filling load of the tray and divide it by the 1.9 kilo weight of the cable, and we get about 8.84 plus change. This number represents the number of cables of that size that we could install. 9 would be higher than 8.84, and so we'd be above the filling load limit of the tray. Therefore, we could install 8 of that size cable to our tray. Of course, it's not that common to have all the same size cables on a tray, and so the first method we outlined is the more useful approach. So now we know the principle of how to make sure our cable trays are capable of bearing the weights of the cables installed on them, we now need to think about how we actually support the tray itself. There's various ways of installing cable tray on walls and ceilings, but these brackets have been specifically designed for that purpose, so we'll demonstrate with them. We've already figured out the weights of the cable on our demo tray to be 13.44 kilos per metre, but now we also need to add in the weight of the tray as well. Information from Marshall Toughlex would suggest it weighs 2.39 kilos per metre. So let's say that we've installed a 3 metre run of this. So that 3 metre run would weigh 3 times 2.39 kilos for the tray, which is 7.17 kilos. Then we need to add 13.44 kilos multiplied by 3 for the cables on the tray. This comes to 40.32 kilos. Adding this to the 7.17 kilos of the tray, we get 47.49 kilos of weight. So how do we know how many of these wall-mounted brackets would be required? Well, again, we need information from the manufacturer. So in this table, we've got a number of bracket sizes and their SWL, or safe working load values, in kilograms. Just a little sidebar here, it's interesting to note that as the brackets get wider, you might expect them to be able to cope with heavier loads for wider trays and more cables, but the opposite is true. This is because the brackets are subject to the laws of physics, which would suggest that as this arm gets longer, any weight or force at this outside edge will have a greater resulting moment on the metalwork of the bracket at the end. Think about the principle of using a longer and longer lever to move something. The same amount of force will have a greater effect at a greater distance. Just an interesting and slightly counterintuitive point of how physics can throw us a curveball every now and then. Anyway, in this case, the 300mm wide wall-mounted brackets we're going to be using have an SWL, or safe working load, of 45 kilos. We need our brackets to hold up a weight of about 47.5 kilos, so we'd need at least 2 of these, which will support the total load. When it comes to spacing these out, I did up the method of dividing the length up in double the number of supports. So in this case, we'd divide 3 metres by 4, which gives us 0.75 metres. I'd put my first support at this distance from the end of the tray, then double that distance to the next one, meaning that both brackets end up 0.75 metres from the end of the tray. Why do this instead of dividing the length into thirds? Well, if you think about it this way, adopting this method helps to minimise deformation of the cable tray, as each bracket is supporting 1.5 metres of tray instead of having a larger distance from the bracket to the end of the tray. Plus it just looks better. Speaking of deformation of the tray, you might have noticed another column relating to the bracket that we're installing. This is marked with a def for deformation, and a value in millimetres is given below it. This value is an indication of how far the bracket will deform or move when it has a weight equivalent to the SWL pressing down on it. It's quite a startling 14 millimetres in the case of our bracket, but this is quite normal. So if you do notice that the brackets have bent down a little during installation, don't panic. It doesn't mean the whole lot's about to fall off the wall. Even our SJs will deform a bit like this when they're being used in the span of a building. This value of deformation is found using some really interesting maths actually, and involves calculus and derivatives. No? It's more like mathemagics really. No one's interested? Okay, never mind. While we've demonstrated this point with just one specific size of cable tray, the same principles can be used for other sizes of tray and basket. So there we go. That's how to make sure your containment can cope with the weight of the cables you install on them. But you may be wondering, if the tray is mounted vertically on the wall, how do I make sure the cables don't fall off prematurely in the event of a fire? Well, to find out more about that, check out this video right here, or click the link in the description below to watch it as part of our free training package to help you with your CPD, and you'll receive a certificate as well. All that remains in this video is to say thank you very much for watching.